Hello and welcome back to another episode of Getting into GiG-37. Welcome back, Sydney.
Sebastian.
Yeah, we left kind of a messy plate yesterday, and today we have to clean it up. Let me compile this. It's not actually compiling even because of this buff. Buff is mutable more than once at a time. First mutable borrow is here. So we use this buffer to get the first parent.
This is the second one already, right? Like this is the second time we use find.
Yeah. And we even use, I mean, it actually doesn't complain about this. So that's a cool thing, by the way. Oh, wait. Here, yeah, here. I was a bit confused because look, I click here, but that's 118. But the line we see is this one. It's the first one, which is here. I was thinking it's complaining because we reuse buffer in a loop, but in fact, that's not the problem at all. Yeah, how to fix that? Yeah, I mean, it's fair. We have to keep commit either is needing that buffer, that exact buffer. That's what we're iterating right now. So in order to see parents, we need another buffer for sure.
Okay.
And we only need one parent at a time. This means 2 buffers should be fine, should be enough. So buff and parent buff. And this kind of stuff, you know, these buffers that we kind of allocate just for that, it's okay, I think. Usually I try to avoid this, or previously in the traversal I had my extra state object and it would allow to pass it in so that people could reuse buffers across invocations, and that might make sense. But now I don't do that.
This is just the simplest form, right?
Yeah, it's just the simplest form, and previously I was kind of overcomplicating it in the name of performance that I never measured. So now I guess I learned that lesson. And it's probably never really gonna be worth it. Probably. Okay, so now let's use that parent buff. And compiles. That was easy. Nice. Field is never used. Unused variables. Okay. Figure out if not having a date is a hard error. Okay, there's this to do. Yeah, we can figure that out later. For now, we just... Oh yeah, right. Search by key. So we want to insert this similar to what git does, which is in the scribe. And they do commit list insert by date. And we should do the same.
So the goal is to do a binary search by the date, basically, and then insert it right there where the output is.
This means the queue should also have a date now. And we don't have that. We don't have the date. We just set flex at 0, but we don't have a date yet for this commit. So now in order to do that,
could you look that up with the binary search basically, or is that too costly? Like the other way is a way of caching it, right?
With the binary search.
So I'm not sure how the binary search works exactly, but my thought was that you kind of give it a where does it get this commit time from? And I thought maybe there's like a closure that then makes this lookup. I'm not sure.
Yeah, the thing is we just need to put it there. We look it up and then we put it there as another part of the queue. So here we would also get the commit time. And then we can use that to insert things. Oh, but you know what? I just realized that this queue here, it can't insert things, I think. Queue Oh, I can insert things. Okay, never mind then. Good, because that's exactly what we'll need to do. Yeah, but this commit time can then be used as a way to order or sort commits. And what's cool is it will always find, if this is a sorted array or sorted vector, it will always find the insertion position. So even if it, usually it doesn't find exactly, it doesn't find an existing commit, even though it might. But we know whatever it does, we always want to insert it in the given position, either the existing commit or whatever it finds there. So whatever number we get, that's where we insert the thing. I think that's what matters here. And it's a stable insertion, I think, so, or it's stable by the way we do it, so these things will always be ordered in one particular fashion. I think should be fine. Yeah, should be fine. Just needs this commit date now, which for the first one we also don't have for this commit. So you see, now we would query this commit twice already, huh? So here we queried once for the parent, and now we queried up there again once for the date.
Exactly.
And then find should really do some caching internally, and it can. Yeah. What's interesting is, I mean, you'll probably see that once we actually try to use it in Git repository. But yeah, I think because, object caching, like previously, I have been bypassing. Oh no, wait, all is good. I think I'm talking, I know I'm saying things which are not true. Never mind, it will be fine from Git repository. We'll be very happy. Okay, good. Then look this up.
Time.
Let's look up commit object, or yeah, I can probably do this all in one line. Committer time is find commit, and then buff, this can fail. Then we get a commit ref iter, and we can get the committer right away. That's cool. So I implemented this already because it's so common. Look what it does. Just uses find map. Makes sense. Find things we are interested in.
Add them to the correct.
So whenever you find, whenever you look for one particular thing, you can do this. Interesting here. Filter map, skip while, author committer. Oh, skip while it not matches author and committer, so that skips parent. Interesting. I wonder if this is a good idea, or this is not actually slower, because this one here does the same thing. Like if I see the author or the committer, I return the signature, otherwise I return none. So I think this is not even needed. So yeah, let's run the tests here. I'm considering this as a flyby fix because it looks more complicated than it has to be. As much as I'm a fan of chaining these iterator methods, let's break it for a moment. I hope it breaks something. Okay, good. So there's test for this. This means that should still work. And it kind of skips over errors anyway. So we could, you know, it should abort once there's the first error. And thus we could say something like take while result okay.
Oh, okay.
And
so if there's an error beforehand, we stop.
Yeah, there's kind of one little test here, which I think is fast. And here we can then match on this because it will not change the value. It's not a filter here. So like this should also work, except for result okay being unhappy. So maybe that's even easier to read. Because if there's an error, we don't really need this. And errors are so rare, you know. I'm even considering to not have this, because if there is an error, it would just return none right away. And none is already stopping any iteration typically. So first time we see none, it's over. So I don't think that this is helpful at all. Yeah, cool. So I think that's a valuable thing. So things stay as simple as they are. Now it's also a bit more similar to this one, which I think is the pinnacle of how you should do it. And what happened there, I don't know. Sometimes you work late and then these things happen. Okay, cool. So committer is what we want. And by the way, something I probably have to remember, signatures. It gives you author or committer signatures, which is these signatures that contain the time. It's name, email, and time of the thing. So this is why I call it signature. And committer, see, it returns exactly the same thing, just of the committer. And yeah, if we ever need a bunch of signatures, we can probably get it like this. Then committer. Oh yeah, that's an option, is it? It's an option. Again, what happens if there is no committer? I think it's the same to do as down there. For now, I probably just do it as before. Map this thing. Oh, come on, IntelliJ. This really takes too long. This is the annoying thing about IntelliJ. It's the same with Clockify. You know, this thing is just so slow because it does the wrong thing and it just begs you to replace it. And this is why, even though generally I like the thing, but if it lets me wait. Now I talked so much, it's more than all the waiting time in the whole session, I suppose, but the waiting time is annoying. Me talking is not annoying for me. Yes. Yeah. Me talking is annoying for anybody else, but here we go. So time. Maybe that's also something that one day can be improved. I mean, there's a time struct, and that time has an offset. So then you read time offset, time sign, and time. That's not so awesome. It could be time seconds since epoch or something. Maybe that's better. Renaming this is quite a breaking change. And it's in Git actor that's kind of used in many places, but I'm happy to make it. I'm pretty sure that there's a reason I named it that way in the first place, but I'm kind of feeling like this I don't want. I mean, there's many things I want, yeah. But this.
I mean, time is the thing you want, but it's true. Then it maybe should be more specific if you already have the struct named that way.
This could also be renamed. But what else is it? Commit instant. Like this time is more like an instant. It's an instant in time. Timestamp. Timestamp.time. yeah, it could be a timestamp. Then this whole struct could also be a timestamp. It's like these are kind of coming in pairs. If I have a time field, this could just as well be the name of the struct. But in any case, even if you look at the struct scope only, I think seconds since epoch, it's better than time, because time is just like, okay, whatever. It doesn't have no unit.
That's very true.
Without a unit, not so nice. Time offset in seconds. Offset also has no unit. So I think just for the unit, it deserves to be renamed, because also just U32, I32. So now I'm convinced this must be renamed. That's a bug, not a feature. And it should contain the unit. And it's seconds since epoch. And this I have, by the way, from here, from std time instant. And there's this, I know it's system time, Unix epoch. Let's just read the docs on this, because not a thing I made up. I just want to know that this epoch, like I don't know the term itself. I just know it as this magic time 1970. I don't know if it really means, I mean, it's Epoche in German, I suppose. So is that a good name? It's Unix epoch, right? It's not just epoch, it's Unix epoch.
A specific Unix epoch. Yeah.
Yes. So I think if I'm writing this like this, I should write it like this, because it's Unix epoch. And people will hate it. Because it's so long, but
you do want the seconds in there, right? Because that makes it specific.
Yes. You could make some type def that says seconds, but then you need 2 because you have an I32, because that can be negative, and U32. So, you know, I'd rather specify it like this. I would consider to have some access methods that give you conversions, like give me this as chrono time. You know, there's the chrono crate, and that really has good time, you know, proper time types, not this. And you could convert that automatically then, and then you say to chrono time or to date time or to date or to, you know, these kind of things. I think
and it's standardized kind of,
yeah. And then you don't really do anything with these manually unless you really are doing low-level stuff. And then I guess it's good that you are never forgetting what this is. So I think that's the trade-off.
You have another dependency, right? Or is that already included anyway?
Yeah. I just say one day. And this dependency would most certainly be optional as well. It's more like I could also do impl time and then have some shorthands for this stuff. Pubf seconds, or but I don't even know what that would be. It's more like I could make it time again, and then you have 2 names for that. But I don't know if that makes it better. I'm just saying there's options. Now you err on the safe side, and I guess this is what I like more. Oh, look at that. Yeah, that's the impact of that change now. It goes through everything. Okay, this needs a proper way of committing this. This will probably take a couple of minutes to commit all things in the right order. So for now, I would just leave it like this and know that it's a bigger change that needs some care when committing and doing change logs and stuff. But now back to where we came from. Was all motivated by this here. Now committer time seconds since epoch. Okay, now it's clear what's going on. Okay, we have this here. Where is it? There. And can put it here. It's kind of the commit time, I suppose. Okay, cool. And now in theory, it should compile. Oh, interesting. Oh, wait. Can it be that I did a mistake here? Yeah, I thought I did rename it using this. Maybe not. Usually IntelliJ does that pretty nicely. Okay, good. My bad. Yeah, cool. Now there should be a way to do a binary search. And that's where I'm like, when I see BB and FF, I'm like, what? What do I have to do here?
I would kind of expect to just give it the key and then.
Yeah. Yeah, so you would, I think you would provide the time here. B should be the time, I think. And F is a thing that returns the time from any of the entries.
Isn't there a simpler function if you just binary search by and then you just have a comparator function, like a closure, and then it's only one input?
Yeah, I think that's true. You're totally right. Binary search by is implemented, by key is implemented like this, huh? So they do exactly what you would do. And it's just a different way of writing it.
Okay.
So yeah, you're right. Let's just take control here.
I mean, I guess once it's written, I'm sure it's easy to understand. It's just before, I think that makes more sense to me at the moment.
Okay, if this makes more sense to you, then we use this and say e2 comp the parent committer date. We will rename that too. Parent commit date, like this. Okay. It's not happy because excuse me. It's an option because I think there's a mistake here. And then rep or default is missing. Which made this commit time actually an option. And now it's the real deal. Cool. That was easy. Somehow I was so afraid of this. I don't know why. I had some mental blockade there. So now we'll do binary search and use as comparator the parent commit date, and only that. And if we have the same commit date in multiple commits, which could happen, it just gives us one of them, but then it also doesn't matter. We just put it in this group somewhere. So the ordering is still correct. It's more like there's multiple with the same that can be happening. That's okay. We could include a secondary way of ordering by just adding another comp here, which is like this, or if it's equal, how is it called? I think it's called then. Yeah, then with. So if these would be equal, then you can say, okay, now we go for the object ID or something, which is always unique. But I don't think it's needed here because we don't really care that much.
Yeah, but we still need a default way, right? Like if the time doesn't exist, I mean, okay, at the moment, I guess we'll just panic, but at some point, probably.
What will panic? Sorry.
If we don't get a committed date, right? At the moment, we'll just no, I'm going for defaults.
It will not. Yeah, it will not panic, but we will get 0 there, and 0 means for us it's always at the end, which also isn't the worst thing. It's more like yeah. I mean, we also have this queue, by the way, to be able to pop front and push back. But now we are inserting all the time. So now we don't even do that anymore. So now this can be just an ordinary vec. And we just have to be sure that we order correctly so we can probably pop back instead. Because we order by time. Is this the right thing to do? Is this still topologically ordered then? Probably, kinda. It's the same thing that the topological traversal does, and I think what it does is it does things a bit differently. It sorts. Yeah, it pushes the parents with the date on top here, and then it sorts them separately. And parents with date. Yeah, but it's okay. Just use this as a vector like we would do. It doesn't have any special thing going on. So this is exactly what we are doing here, and that works. So in order to do a topo search by commit, topological search, and then also have it sorted by date, you would do exactly that. You sort everything by date. And I think this is inefficient the way this is done because you can just do an insertion.
No extra sorting needed afterwards.
Yeah, no extra sort needed.
But you are reversing. I mean, I guess that's also just a way of how you compare, right? Or where you insert.
Are we reversing? I mean, yeah, here it's exactly what we would expect. What does it do? Does it pop? Does it pop from the end? What does it do with parents with date here? How does it get the next one? Next. It has a next queue and it has a queue for parents. And how does it fill? You know, what's a bit strange here? This parents with date, it's never cleared. So when is that cleared, you know? Like here, it doesn't consume it either. But here it pushes it onto next. And then yeah, it's cleared. Right, it's cleared here at the beginning. Next commit by date, and that's happening each time you call next on the iterator. Okay. For a moment now I was thinking there is a huge issue. Okay, but here's the answer. It still has a queue, but what it does is it sorts only the parents by date. And this is how it maintains a topological date ordering. Because these parents are sorted by date and then are pushed back onto our actual queue. Whereas what what I was about to do now here was to have one queue and that's sorted by date.
Right.
But then that's not the same as the traversal.
So you just bring the two parents into order, but you still keep the overall structure.
Yes. But is that what Git does? That's the thing. To me, it looks like let's check how it gets its item to iterate. Is this using the list or am I missing something? Yeah, while list, pop commit. And pop commit pops from the top of the stack. So that's a pop back, takes from the end of the list. Okay, so maybe we have to do the same thing then. So we can just use a vec, I think. Pop back. Yeah, that's the beginning of the list here. This is what it does. No, the beginning of the list. It pops front, sorry. It pops from the front. And the front is the newest, the latest, the most recent commit. Yeah. That's what I see. And yeah, look, this is really just a list and pops front. So we use the vec tag where you can pop front and then you insert in places and that's it. Yeah. It's different from what is happening in the iterator, but that's just how it is, I guess.
Should work.
Yeah, probably. Since Git is doing it, I'm pretty hopeful that it will actually work. I
for us.
Yes. So oh right. I think the most important thing is that this is actually the right order, because this is ascending now. 0 is first and high numbers are at the end, but we want it descending. So what you do there is you just reverse the ordering. And this is how you get the other way around. So ascending by default, but reversing means it's descending. And this is how you get newest first, essentially. And newest is first because that time, seconds since epoch, it's always increasing. So the big numbers are the ones that are more recent. All right. Now, what does this return? Oh yeah, and one more question. I'm a bit concerned that this is, inserting into a vectag. Like, think about a vectag. Vectag is a vector, but it has this midpoint notion, so it's more like a circular thing, I think. And I wonder if the binary search is custom for the vectag. Yes, it is. Okay, vectag has a custom implementation of a binary search, which means it will probably do the right thing. Good, then I'm okay. I didn't want kind of this automatically dereference to some slice and then, but it doesn't do that. It doesn't deref into a slice because it can't. It's two slices essentially bound to each other. So yeah, it's properly implemented. It's a Rust standard library. What am I talking about? Of course it works. Of course. Paranoia. Okay, so then we have an okay. Then we have some insertion point. We get an okay where we can find an existing item, or we have an where we should insert the item that we are interested in so that it's ordered. So means it isn't found. There is no item that has this particular parent commit date. but here you can insert it so that it stays ordered. And that's how you can quickly build ordered things, and you don't have to kind of sort them from scratch all the time, like is happening there. Probably doesn't matter. I wouldn't change that code now in the traversal, but this is what we do here. And I wonder how I get that number no matter what, because we always want to insert there. We don't really care. Yeah.
So yeah, okay. So also in the OK case, basically, we just wanna use that number.
Yeah, any number, and OK, anything. And I think there's no way of doing this because that's so uncommon. So you really have to match on it, and there's no fancy function for it. Yeah. So now we have our queue. I want to insert this thing at insert at. Yeah, we can probably call this at. Then this looks a bit better in this context. And here we have this tuple of object ID flags and U32. Now it gets interesting. Object ID is the parent ID, which is just called ID here. ID. And I think that's owned already. That's great. And then the flags. The flags are our parent flags and nothing else. Or is there something special?
Copied over, right?
Yeah. And that's the weird thing here. We don't copy it over, we add to it. Like this could already exist somewhere. Like this shouldn't be stateful. But that's the question. Is it stateful or is it not? Because right now we are not really stateful. We can only pass on from step to step. But I think since here I think that's that. If it's not seen, then we insert it, but otherwise it can be stateful. So we can see the same object multiple times, and then we expect to have state, but we will only we only traverse parents once, but we can reach an object multiple times, and we will adjust its flags accordingly. But I wonder what this even does if we adjust the flags like this, because this does nothing now. And it will not do anything because the next round is here, but we didn't push it on the list. So these flags, they're useful here and here only. This is where they're used, so as to increase the depth. So yeah, I don't know how this is important, but it could be. Could be a subtle thing that is important. Oh, and by the way, remember last time I commented this out and ran the tests, but they all work. So there is no test that actually exercises this code.
Yeah, I mean, this might be only for more complex tree structures, right? Like the simple ones that we saw in your tests.
Yes, but usually they do have tests for everything, especially when somebody adds. I would expect that, but apparently not in this case. Describe is not that important, even though it sounds like it when you read this commit that was made 15 years ago. Oh my god. We're now implementing something that is 15 years old and used since. It's crazy and still kind of struggling. I mean, it's not super trivial. Struggling a little, not crazy struggling, but it's okay.
Not obvious.
Yeah. Anyway, to answer that question, flags in our case must be the flags of the parent because we have no state. There is no flags here. And our parent commit, the flags are here. And now the time. parent commit date. Okay.
And this ORing, this bitwise ORing over that they do is the same as assigning, right? That's basically what it does.
Yeah, it's more. As I said, it's more, but we don't have anything. Like there is no flags for this parent, obviously. There, we give birth to the flags with 0 here as we read a commit, and then we pass it on, and there's only one place where it can be set, which is, yeah, where is that place? It's here, right? I think we don't do that, do we? I don't think we do that. Here, see object flags. I think here's where it should be set. And we don't do that yet. So right now we pass on 0 everywhere. Yeah, so that's the identity bit. And we do want to set it like this. Oh, it's super slow now somehow. I don't know what's going on with IntelliJ. But yeah, now we start to use flags actually, and we can only pass it on because we have no state. But I honestly, like, we can reach the same commit for multiple areas, for multiple parents. And I think that's the problem here. Like, if we come from this branch and we reach this, we can pass along information from this particular branch to this one. If we come from here, we can pass it on to this one. But right now that doesn't happen because this one gets its own copy of that one and gives it its flag. And this one gets another copy of the same commit and gives it its own flag. So we don't ever get both flags.
Yeah, it's not merged.
It's not merged. And I think this is why we need to keep track of this specifically. So the queue is one thing, but the flags need to be associated with the object ID. And somehow they do have persistent objects here. They have some hash map and they only get it once. But we don't right now. And I think Git is more efficient in this because they have this. Look what Git does. For Git, every object, that's a commit. It has a baseline object struct in here. And each object has flags associated with it. A bit flag that says I'm parsed, and then 3 type bits, which says what kind of object it is. And it has the remaining bits of a usize, 28, set so that they can be used by anybody. So any object you get has flags. And also knows its own object ID, which is even also not the case for GitOxide objects. And because of the way the object database works, it always caches recently accessed objects in a map or something. So you always get back this one and not some new one that happens to be the same, have the same identity. And this is why they, for this kind of stuff, they only need their one map that is built deeply into the object database. And we always need an extra one. 2 maps. And that probably is I don't know if it's a good thing or a bad thing. I just know they need 1 lookup less. Because the find implementation here can implement its own map to keep track of, return the same buffer for the same object and not look it up again. But we need our own mapping here to just keep track of flags.
Yeah, it's completely separate from
yeah.
everything.
And that's okay. I mean, that's okay. I wouldn't ever want to bundle this so much, that I would rely on that. Like, how can you rely on this kind of capability? I would not. I can't. But that could also be a performance issue at some point because you just have you need 2 accesses. And I don't know how to how to get rid of this, like this intrinsic flex thing. It's a real feature. And just adding flags to our objects even doesn't work at all, because that's iterators. They iterate buffers. You can't modify the buffer. You can't do it. You simply can't. Doesn't work.
Yeah.
But it's okay. I consider it an advantage in terms of clarity, even though, yeah, maybe this is going to be slower, let's say. Yeah, okay. Also, I mean, let's not forget to make it like this. Flags need to persist. And we need to keep that alive for later as well. So that can be a big hash map potentially, because we travel through the whole graph theoretically, huh? So we build up a map there. Yeah, we need some memory there, unfortunately. I like the queue idea here. That would be clean and simple and small, and this one here, not so much anymore.
Yeah.
Yeah, I'm thinking, maybe we can detect whether something is merged and is done, and then you can kind of remove previous objects from the map once you know things, but I don't know. Seems like a task for another day. But one thing I think is missing here. Insertion should only happen if we didn't see it yet, huh? Yeah.
Yeah. Are we keeping track of that already?
Yes, we have another hash set for that. Haha. Another big boost for these guys here, where they just have intrinsic storage for stuff like that and can say, hey, I mark you as seen, and I don't have to use a hash map for this. And that, I mean, when I think about how hard it is for me to match the performance of pack creation, for pack creation, they do the same thing. They remember objects that have been seen, not by ID in a hash set, but by marking them. And that makes it so much faster.
Yeah, it's such a cool idea as well, because you're going to be using this feature quite a lot if you work with these, like with objects in general.
Yeah.
And yeah, I get it. It's weird. It's kind of hidden away, but it's also super convenient.
Yeah. I think what has to happen is that Git-Oxide has to provide a separate trait or something that has the object lookup, the object map built in, and allows you to associate data, any data, with these objects. And then you can just use that object caching maybe along with custom data. And that custom data could be an empty tuple unit, 0 size. Could be 0 size by default, but could also be whatever you want it to be. And then you only have one lookup plus additional data associated with this. And I think then you can win.
This would be handled by the caching mechanism, basically.
Yes. And this would then boil down to some find that is able to persistently return data to you. Not just the commit ref either, but it can also give us, for example, a use size or something. Or, this flags. This flags should come with find. And then we can outsource this to the caller, who can then make it efficient. Right now it's not efficient because you still need 2 hash sets, but this could be made so that it is potentially efficient. But yeah, don't get me started with generics, because I know the whole underpinning is not generic, and you don't want it to be generic, because then you have a generic type that is dragged through all the types up to repository, so to say. Like, at some point you have to decide what kind of thing you want there as data, and probably just flags with use size or something, or even just a 32-bit thing. And that's how you would have to do it. But then that's as good as it gets for Git-Oxide, I think. But why not? But then you need an object cache and must be big enough. And right now there's even a limit for this kind of thing. It's just not unlimited, growing unlimitedly. And I just don't know how the whole I think I don't know yet well enough how the whole caching mechanism of these objects works, because they can't just go out of memory, right? So when they have to throw stuff away, and I just don't know. But yeah, I think that's also for another day. Like optimizing the persistence and making it more a bit like Git really. But definitely, we have to scene, do we? Yeah. So if we inserted it successfully, then it's new for us. And then we can do this. I was just thinking that's too good that it compiled the wrong thing. Buff is not in scope yet. Yeah, wow, but it does run. Okay. So now that actually traverses the whole graph and collects information, and we just don't do anything with it. Maybe as an end of this session, we can have a look at what the test would do now. Maybe do some debug printing, and that's it. I would hope it already does something useful. Bug. Shouldn't ever see dupes here. Really? Okay. Oh, that's interesting. Oh. No, wait, that should be true. It returns true if it's new. So that should always be true. Scene, we insert the commit. Ah, I see. I think that can't be done here because we already put a parent. We already inserted here, and then it's on the queue, and then if we insert it here again, it's false, and then this triggers.
Yeah.
So that's us. Okay. Not yet implemented. Actually search for it. That's cool. So let's see what kind of candidates we have here. Oh. Candidate does not yet have debug formatting. That's fair. Okay. Is this what we want? Commits in future 7?
That is what we want, yeah.
Really? Are you kidding?
If I remember correctly, yeah.
Okay, let's look. Ooh. No, hex length 7. I'm very excited now.
No, it's not.
3. Should be 3. It's 7. Okay. Yeah, that's figuring out why that's not working is definitely for another day. But it's already doing something. That's great. It counts all the commits.
Yeah.
And why that is, we will find out soon. It's maybe has to do with flags because we have this merge commit and we don't have persistent data, right? And you know, this scene, I feel, you know, we already do this. So we can do it like this. We can have a hash map and insert the flags themselves. Huh?
Yeah.
This also means for the initial commit, do we need to insert that 0 for the initial commit? I think we need to do that because that can never circle around. I think that's okay to not have that. But then that returns an option now of the previous value. And this means we have two ways to insert this, one with previous flags and one with existing, with no previous ones.
Okay, yeah.
Because one time we get this whole tuple thing with flags. So none is this one. And I just copy paste this now. Some, that's the ID, that's the flags we're actually interested in. Previous flags. And that's the time we're not interested in. Oh yeah, right. And we insert at ID. We insert 0 flags. And that might not be used after all. Oh no, wait. That's not true. It always inserts, but it overwrites the key that is already there. Can't do it like this. I have to use entry. Entry. So and then you get a
entry and then
yeah. Entry. Oh, I always forget this. How do you call this? It's a connection hash entry. B-tree map, hash map. Hash map entry. Yeah, that's good. Okay, now we go with vacant. And that's like before, where we just pass on the existing one. And occupied entry allows us to get access. Yeah. To the previous value. Oh, you know, and now we also have to edit that. Like we have the new flags. And we have two locations where this data is stored now. We have it on the queue and we have it. Yeah. Oh, man. Right. I think this wants to be redesigned to not have this double data. You don't want it here anymore. You just, and that kind of is nicer because now it only has what it really wants to have. Flags. But now we have to pull it from scene. And the first one isn't seen, so there we just make it up, I guess, the flags. But we do have to put it on top of, I mean, yeah, we have to put it in now because we need flags here. Always. So now we have to initialize it with 0 so that the first one has something. Insert. like this. And now we look it up when we need it, and it's expected to exist. And it would exist because we always insert this before we arrive here.
Next. Mm-hmm.
I don't know if that insertion works, but so here I would say scene get mut, and this just has to be there, and we expect that. Borrow OID, interesting. I think that's me here doing a double borrow. What's this one? We call it commit, okay. Inserted. Okay. Cool. So now we set the one that we memorized, and what's a bit sad is that now before accessing it, now we have to access it again, like once mutably here. And for all the other parts, we access it again here once. And that can just be get this, or can be this. This panics automatically. And now that I'm thinking about it, since you want the panicking version anyway, we can actually do it like this. And that will automatically do the mut thing, because it knows it's in a context where it needs mutability. So that should just do the right thing. Now we have flags, the original ones, back to this one. And now we insert the entry. It's interesting that because entry should need the key. Oh. What do we get as input here? What's commit initially? It's an OID, now I understand. So we do want the OID to owned here. And now this matches down here again. There we go. Now the key is an object ID and not a borrowed OID. And we do have flags. So if it's vacant, we want to insert it and use what's there. I think now this can be easier. No, wait, this can't be easier, because if it's already there, we do want to combine both values. And insert it into the queue.
But the queue, yeah, the queue insert is always going to happen the same way, right? It's just the way that we combine the flags is different. Actually,
wait, it's only going to happen once. So if it's empty, if it's not yet there, then we want to insert it. But here we don't want to insert it. Here we want to change the value. Here we want to insert it. Yeah, here we want to insert it as well. But here we have to change the value. I think that's the difference. Okay, so let's insert it. Entry. So here we can just insert the value. The value is flags because it's a new value. And we insert it at this location, and the queue, we put the parent, we put the ID in at the right location as well. And when it's occupied, we don't do anything except for just adding the flags. Entry get mut. enough. Okay. So let's see. Does that compile? Flags not found in the scope. Okay. I do this a little late. Yeah, so that's read only. That's good. Integer cannot be dereferenced. Ah, this means that scene does not know what that is. So that's actually a U32 or U size, depending on what we want. How many candidates do we want to support? That's the question here. So
Just get used 32, right?
yeah, git use U32. Now we do 2. We even support more because we don't have any other bits that are used for other things. I really have to see how Git stores its objects that it caches somewhere. Is it just a linked list or something? Like, how does it keep it fast and be able? How is it able to look them up quickly? Because okay. Oh, identity bit is U size. Yeah. Oh, wait. That's actually flags here. Remember I had my great hype flags to do exactly this. So I think now this has to move here at least. And now this should be unified again. Okay, getting there. And the binary search now, just this field that is the tau, second one. Oh, index mat is not implemented. Okay, interesting.
So that just means you can't get it this way. You do have to get much.
Yeah. Can I do this? That I can do. Okay. Cool. Do we still print it? What's the number? Still 7. Nothing changed. Was worth a try. Okay. I keep that debug printing there. Turn off the stupid test. And that's much better. So that's a nice cliffhanger for the next time where we will have to fix that. Can't wait. Yeah. So thanks a lot for watching and see you next time. Bye bye.